Hello, this video is to go over mole conversions. This video is going to cover two-step conversions. So using this flowchart, we would be going either from atoms or molecules to mass or back the other way from mass to atoms or molecules. You will need a periodic table to do these problems since we are going to be multiplying or dividing by the atomic mass. That's the number found on the periodic table. And then we will also be using Avogadro's number, 6.02 times 10 to the 23rd. This is the number of atoms in 1 mole of any substance, the number of atoms or molecules of 1 mole in any substance. First, let me just show you how we're going to do these. So if you are given grams, so you have a question like if you have so-and-so grams of a substance, how many atoms or molecules do you have? You're going to follow the bottom path. So first you're going to divide by the atomic mass, and then you're going to multiply by Avogadro's number. If you are given a question that goes the other way, if you are given the number of atoms or molecules, so it's atoms if it's just one element, it's molecules if it is a compound. So like if the question says iron or copper or silver or whatever, that will just be atoms. If the question has a molecule compound like H2O, CO2, something like that, that will be molecules. Don't get hung up on that. The process is the same. So if you're given atoms or molecules, you're going to follow the top path. First, you're going to divide by Avogadro's number, and then you're going to multiply by the atomic mass. And we are going through moles to get there, but moles are just going to be a placeholder in these problems. This question says, how many molecules are in 25 grams of carbon dioxide? Carbon dioxide is CO2. Since this is a two-step problem, I'm going to set up my train tracks like this. So I should have 3 columns, 3 sets of boxes, and the number and the unit from the question always goes in the first box. So 25 grams carbon dioxide in the first box. We do want to keep track of the unit and the compound or element. Right now it doesn't seem like it'll matter, but when we get to a later unit, it'll be important to have those on there. So the number from the question always goes in the first box, and then let's follow my path here. So the question gave me grams, so now I'm going to need to divide by the atomic mass. Another way to look at this is the unit that you have on top, you always want to have the same unit on the bottom in the next box. So I've got grams of carbon dioxide in the first box. I want grams of carbon dioxide on the bottom in the second box. So since I am dividing by the atomic mass or the molar mass, I need to find out the mass of this compound, carbon plus oxygen times 2. When I put those in my calculator, I got 44.009. So if you're using the Desmos calculator, just plug it all in one long step. Carbon plus oxygen times 2. And that's my mass. So that's going to go on the bottom there. 1 mole is a placeholder. This is going to go on top. 2 things together equal each other. So 1 mole of carbon dioxide is equal to 44.009 grams of carbon dioxide. I'm not going to round my atomic masses or my molar masses. I'm not going to do any rounding until I get to my final answer. Okay, now I have 1 mole of carbon dioxide on top, so I need to have 1 mole of carbon dioxide on the bottom in the next box. Okay, and 1 mole of any substance is equal to Avogadro's number, 6.02 times 10 to the 23rd molecules of carbon dioxide, and now I am ready to solve. Whenever you are plugging these numbers from your train track into your calculator, any number that's on the bottom, you are going to divide by it. So I'm going to start out with my number from my question and then divide that by 44.009 and then multiply that by the number on top, multiply that by Avogadro's number. Any number on the bottom, you divide by it. Any number on the top, you multiply by it. And anything that's a 1, you can skip it because anything times 1 is itself. Let me show you that these units also cancel out. So since I have grams of carbon dioxide here and grams of carbon dioxide here, 1 on top, 1 on bottom, those will cancel. Moles and moles will cancel. And so when I'm done, I'm left with molecules of CO2 as my unit for my answer. And the question says, how many molecules are there? So I know I'm doing good here. 25, you don't really need the 0.0, but I'm going to put it on there for you. And then divided by 44.009, and then times, whoops, we want to make sure we're over here, times 6.02 times 10 to the 23rd. To do an exponent on this one, you just press this little A to the B. The little B is like the exponent, 23rd. Oh, we don't want to do another exponent. Okay. And it's good practice to put your scientific notation in parentheses. For this question, it's not going to matter, but if you are dividing by scientific notation, then it does matter. So it's just good practice to keep that all together. So when I plug this in my calculator, I got 3.41975 times 10 to the 23rd. Since my question over here had 25.0, that's 3 significant figures. My answer, I'm going to round it to 3 significant figures. Don't forget the times 10 to the 23rd. Both of these parts of the answer are just as important. So if you just say 3.42, that is wrong. You need 3.42 times 10 to the 23rd, and my unit is molecules of carbon dioxide. Our second question says, what mass of iron is 8.7 times 10 to the 23rd atoms? So this question, I am starting out with atoms, and I'm trying to get to mass. So now I'm going to be following the top path here. So I know this is going to be a two-step problem. So I need to set up my, set up my train tracks with 3 boxes. And the number and the unit from the question always goes in the first box. I went ahead and added the element on there too, 8.7 times 10 to the 23rd atoms of Fe. Fe is a symbol for iron. Now looking at my path, let's see what I need to do next. I'm starting out with atoms. Now I need to divide by Avogadro's number. And remember, our unit always drops down diagonally. So since I have atoms here, I know I need to have atoms on the bottom here. Avogadro's number, and then 1 mole of Fe on top. That is my placeholder. Remember, 2 things together equal each other. So 1 mole of Fe equals 6.02 times 10 to the 23rd atoms of Fe, atoms of iron. And then I'm going to multiply by my atomic mass. On the periodic table, iron has a mass of 55.845 grams. And now I'm ready to solve. Everything on the bottom, you're going to divide by it. Everything on the top, you're going to multiply by it. The ones, you can skip them. I'm going to put my scientific notation in parentheses. 8.7 times 10 to the power of 23. Close my parentheses. And then since Avogadro's number is on the bottom this time, oops, I want to divide by it. So I'm going to go ahead and put that in parentheses too. 6.02 times 10 to the power of 23rd. There are different ways to do this in your calculator depending on what calculator that you're using, but I'm just kind of showing this one because I think this is the method that is most convenient for us right now. So the number from the question, 8.7 times 10 to the 23rd, divided by Avogadro's number, times the mass on the periodic table, gives me 80.706222924. My question only had 2 digits, so when I get my final answer, I'm going to round that to 81 grams of Fe. If we go back and look at the question just to make sure this is a reasonable answer, if I have 8.7 times 10 to the 23rd atoms, I have a little bit more than 1 mole of atoms. 1 mole would be 6.02. I have 8.7. So I have more than 1 mole of atoms. So 1 mole of iron would weigh 55.845 grams, and my answer is 81. So that's more than 1 mole of atom. So just like a quick way to check and make sure your answer kind of makes sense.